Assalamu alaikum. So today is our lecture 7. So इससे पहले हमने जो लास्ट लेक्चर में देखा था we have seen partitions and law of total probability and उसमें हमने देखा था कि कैसे partitions को यूज़ करके हम किसी भी इवेंट की probability निकाल सकते हैं. So today our topic is Bayes theorem. Bayes theorem. This is very interesting topic because it says that when we have advanced information about probability of A given B, means we have been given the conditional probability in this manner and need to calculate probability of B given A. So we can use the Bayes theorem. So the Bayes theorem, it is theorem 1.11. It says that probability of B given A is equal to probability of A given B into probability of B divided by probability of A. So this is very simple and interesting theorem because it says that if we have the have the advanced information of certain probability that probability of event A given B, and we need to calculate in the reverse order that we want to find the probability of B given A, so we can use this theorem very easily. So it is extremely useful for making inferences about phenomena that cannot be observed directly. So sometimes these inferences are described as reasoning about causes when we observe effects. So to understand it, let's solve a very basic problem. It's example 1.20. So I will copy and paste it from the book. So okay. So in the previous example that we have seen about the resistor manufacturing, and we have learned certain things. We have calculated these things, that the probability that a resistor is from machine B3 is 0.3. The probability that a resistor is acceptable, that is within 50 ohm of the nominal value probability of A, which is we have calculated 0.78, Given that the resistor is from machine B3, the conditional probability that it is acceptable is probability of A given B3, which was given in the previous example. Now what we want to calculate is what is the probability that an acceptable resistor comes from machine B3. So when we will pick the resistor out of the box of the 10,000 resistors, so what is the probability that the resistor that we have picked is acceptable and that comes from the machine B3? So it means that we have to calculate probability of B3 that is acceptable. Okay, so what is the probability that an acceptable resistor comes from machine B3? Means if we choose acceptable resistor, means we have chosen, means it is supposed that we have chosen acceptable resistor, and what is the probability that this resistor is manufactured from machine B3? So according to the Bayes theorem, we know that what is the probability of acceptable resistor from machine B3 and probability of B3 and obviously probability of A. So here, as we know that all the information, obviously we have calculated some of them from previous example. So probability of A given B3 is already given, which is 0.6, and probability of B3 is 0.3, and this is 0.78. So this is 0.23. So from here we can clearly see that 23% resistors are from machine B3 which are acceptable. Similarly, we can find out the other probabilities. Probability that it comes from B1 given A. So it will be simple. Probability of A given B1 into probability of B1 divided by probability of A. So again we have all these information with us, and by putting those values, what we will get is 0.31. Similarly, we can calculate for B2 given A is probability of A given B2, probability of B2, probability of A. Again we have all these values, so 0.46. So we can see that 31% resistors which are acceptable comes from 31%, and this is 46%. So these resistors, 31% comes from machine B1 and 46% comes from machine B2 for all the resistors that we have manufactured from these three machines. Okay, let's see another example. I will paste it on new page from the book. So this is quiz 1.5. It says that monitor customer behavior in phone smart store. Classify the behavior as buying, if customer is buying, if the customer purchases a smartphone, otherwise the behavior is no purchase. Classify the time a customer is in the store as long if the customer stays more than 3 minutes, otherwise classify the amount of time as rapid, means if the customer leaves before 3 minutes. Based on experience, okay, so with many customers we use probability model that the probability of no purchase is 0.7, probability that customer will stay for long is 0.6, and the probability of n intersection L is, means that is not buying the phone and is staying in the store for long, for more than 3 minutes, so that is 0.35. So if we again look at this question, it's very interesting that customers are divided into whether they will buy a phone or not buy. So obviously they are different, means there is no overlapping, because if someone is buying, it cannot come under that customer is not buying, and so on. So we can say that these two make one partition. Similarly, if the customer is staying for long, so it cannot leave earlier because it is leaving after 3 minutes. So obviously they are again making another partition. So we can use the previous theorem, and we can draw the table for it. So we can say that L or rapid buying, not buying, and we will fill this table with all the information that we have given. So probability of not buying and staying long is 0.35. Probability of not buying is 0.7, and probability of staying long is 0.6. One tip here, you must remember that these values, they will sum up to 1, and these values, they will also sum up to 1. So this will be 1. So obviously if a customer is staying for long, the probability is 0.6. So customer that will go before 3 minutes, obviously that should be 0.4. Similarly, if the probability of not buying is 0.7, and so the probability of buying would be 0.3. To fill up the rest of the table, we can see that probability of, say, not buying is actually probability of NL plus probability of NR. Now as we have these some different values which are given, probability of not buying is 0.7, probability of N intersection L is 0.35, plus this is unknown. So from here we can see that probability of not buying and leaving rapidly is 0.35. So here we can see 0.35. Similarly, probability of staying more than 3 minutes will be probability of BL, probability of plus probability of N L. So again we have this value 0.6, and probability of this is unknown, plus probability of not buying and staying long is 0.35. So from here probability of buying and staying long is 0.25. So here we can fill 0.25. So now this last cell, this is quite easy to fill because this must sum up to 0.3, so that will be 0.05. Now this is what we have done so far to fill out the table. Now we can answer the questions which have been asked. So let's see what is the first. Probability of buying union probability of means we have to find this probability of B union L. So A, probability of B union L. So this is obviously probability of NL, because we have to take the union, so they all will come here. BR. This we can see from the table clearly, that probability of B, which is this one, and probability of L, which is this one. So we have to take 1, 2, 3 cells. So we have written all those 3 cells here. So that will be 0.35 plus 0.25 plus 0.05, which is 0.65. The second part says that probability of N union L. Similarly, from the table we can say that probability of N plus probability of L minus probability of NL. So probability of N union L, so probability of N, which is this one, union this one. So obviously we have to remove this probability, because if we look closely it is coming twice, so obviously they are not mutually exclusive events, so there will be some common, so we have to remove that one. That's we have discussed earlier. So that will be 0.7 plus 0.6 minus 0.35, which is 0.95. So next part, it says that probability of N union B. So if we look at the N union B, N is this one and B is this one. Now if we see that probability of B is 0.3, probability of N is 0.7, and they are mutually exclusive events, and they are obviously making partition, so they are making the sample space, so we can simply write from here as that this is equal to probability of N plus probability of B, which is probability of sample space, which is 1. Now the last part, I will try to choose some other color, say this one. So probability of LR, probability of intersection of L and R. Now if we see the probability of intersection of LR, from here we can see that these are partition, and by the basic definition of partition, they must be mutually exclusive and collectively exhaustive. So therefore there is nothing common in between them, so obviously this will result into a null set. Sorry, I will write it like this: probability of null set, and from the basic definition we know that the probability of null set is 0. I hope you have understood this topic carefully. So I will urge that you may start solving some problems from the back of the from the end of the chapter 1. They are given topic wise, so just solve with some questions from there, and best of luck. Assalamu alaikum wa rahmatullahi wa barakatuh.